Okay, so today we're going to be talking about the post lab for Freefall. An object is said to be in freefall when gravity is the only force acting on it. So what we have here is two pictures. We've got the first picture here of someone shooting a basketball. Even though they're throwing it upwards into the air, it is thrown upwards, but it's still in free fall, even though it's traveling upwards. So the reason is because when it's in the air, gravity is the only thing acting on it. Likewise, the famous Isaac Newton, when the apple falls on his head, that apple was in free fall while it was in the air because gravity is the only force acting on it. So the investigation that we did today involved graphically and mathematically modeling the relationship between position in time and velocity in time for two objects with different masses. In the lab today, we talked about, we used a golf ball and we used a tennis ball that are in free fall, and we are sending them in free fall by throwing them into the air. Okay, so first up, we had a golf ball, and I just took this. I had a student help me with this video. We took it in the red hallway, and I've thrown the golf ball in the air. Looks like this. And what we did was we did the motion analysis on Logger Pro, and we tracked the object's motion using Logger Pro, and it produced two graphs, the position versus time graph and the velocity versus time graph. So here's the first position time graph for the golf ball before it hit the ground. Notice that it has a mass of 46 grams. It's going to come up later. But based on its parabolic shape, we can tell that the position time graph is curved. Therefore, it's accelerating. So if we look at the velocity versus time graph for this, we see that it's a linear line and that it does pass over the 0 for velocity. And what that means is that at the very top of the ball's path, that it pauses for a moment. Okay, so what that goes with on the position versus time graph is the parabola. So at the top of the parabola, the tangent line is going to be horizontal, and that's what that means, that the slope is 0 here. If we were to try to write the mathematical equation for this, we would find velocity is equal to negative 10.38 meters per second squared times time plus 23.38 meters per second, where 23.38 meters per second is the initial velocity and negative 10.38 meters per second squared is the slope or the acceleration. Okay, so for the second part of the lab, we did it again, but with a tennis ball. Here's what the video looked like. Okay, and we tracked its motion to just before it hit the ground there. Let's compare our position versus time graph. And here we see the position versus time graph is actually the same shape. It's a downwards opening parabola, and we get that at the peak, the tangent line is horizontal, which would show us that at the top, its slope is 0. So let's confirm that by looking at the velocity versus time graph. And that's right, at the velocity versus time graph, there is a part where it pauses for a moment because it does cross the time axis where the velocity is 0. So it does pause for a moment. Coming up with a mathematical equation for this, we have velocity is equal to negative 10.16 meters per second squared, or meters per second times time plus the y-intercept, or the initial velocity of 22.76 meters per second. Okay, so the conclusion of today's lab, which we did at the end of class, was that we have very similar accelerations for both the golf ball and the tennis ball. They're both in low tens. However, what we would find if we were to perform the experiment in a vacuum where there's no air, that the slope would have been negative 9.8 meters per second, or negative 9.8 meters per second squared. Okay, and this is the generally accepted value for acceleration if something's in free fall, and this is the value we're going to use in class. Also, on top of this, we also have this very important idea that the acceleration due to gravity of an object is independent of its mass. Okay, you'll recall that from the previous slides that the golf ball and the tennis ball had very different masses, and yet they were very similar in acceleration. Okay, so that's one conclusion and one moral for this lab, is that mass has nothing to do with your free fall acceleration. And also we have this new constant here where we can say that the acceleration due to gravity is negative 9.8 meters per second squared. And that negative sign just means that everything in free fall accelerates downwards in a negative vertical direction. What this means in terms of your homework is that if anything is ever in free fall, based on what the problem describes, whether someone's throwing a ball in the air or if a baseball is hit for a pop fly, we do not have to tell you the acceleration. You are just supposed to know that the acceleration is negative 9.8 meters per second squared when something's in free fall. Okay? Ask me questions in class and we'll talk more later.